Okay, so this video is probably going to be more fitting to like a first semester physics course, but it's something that I guess would, if nothing else, be good review, and if it helps somebody, if I ever make a playlist on Physics 1, maybe this video will be a pretty good fitting early video. Mostly talking about mass and kind of how to think about it. And I found this little picture where it talks about weight compared to mass, where weight is a force due to gravity, and mass is basically how much of you there is. And the way I think mass is we should define mass is, well, there's different kinds, but we're going to define it like this to start for physics. We're going to define it as a measurement of an object's inertia. Now, just to review, what does this mean? What does this word mean? The way that I would think of this is its resistance to being accelerated. There we go. That's what I would think of. So let's think about about that a little more conceptually. Let's say we have a big rock, a big, heavy rock. And you're trying to push it. You're exerting a force onto this rock. But as we find out, because the rock has so much mass, it has a high resistance to being accelerated. So that means it's going to stay at the velocity that it's currently in. So because the velocity of this rock, it's at rest, right? So the velocity equals 0 because it's at rest. It's going to stay at rest unless you apply a really, really big force, because as we know, force equals ma. Okay, so we're going to need to apply a really big force to get this to move. Now, let's think of it also in another way. Let's say we have this frictionless slope, and we have the same big rock. It's the same one as before. And let's say we're getting it to roll down. Oops. Let's say this has some velocity. Now you want to stop this big rock. He's also sad because he's about to get crushed from rolling down the hill. You're also going to have to exert a really big force to get its acceleration, because right now, it's moving this way. We want the acceleration to go this way. So you're going to have to apply a really big force to get that motion to change of the rock. Okay? Let's talk about our units real quick. Our units, kilograms, which there's interesting stories about, a chunk of metal that we're saying, oh, this is how much a kilogram is. It's pretty arbitrary, but we're comparing all other mass to this chunk, and we're calling it a kilogram. Okay? Now, weight, just as the picture showed above, that's a force. That's a force due to gravity. Okay? So we have a gravitational mass, so we have a gravity mass. And we have an inertia mass. Well, it turns out these two things are equal by the equivalency principle, at least equal in the sense of measurement. Should be an I in there. There we go. Equivalency principle. And we'll talk more about this in future videos. I just want a little introduction. The force due to gravity, this is Newton's laws of motion, or Newton's law of gravitation, is G, the mass of one object, times the mass of the other object, times the distance between them squared. So this is Newton's law of gravity. Okay, and G is a constant, so that's 6.67 times 10 to the negative 11 newtons times meters squared over kilograms squared. Okay. And on Earth, which is what we'll do a lot of, the force due to gravity is just mg. Okay. So that was just a quick introduction to mass and how we can kind of think of it. We're going to start getting into some Newton's laws of motion and working more with gravity here soon, but just a quick